So let's compare mean and median as measures of central tendency. I'm going to copy down again a data set that I used in the last video. I had the numbers 29, 35, 47, 53, 60, 64, 69, 71, and 80. And you may recall, if you watched that video, that we found that the median was 60. So I'm also going to calculate the sample mean for this data set. 29 plus 35 plus 47 plus 53 plus 60 plus 64, 69, 71, and 80. So I need to take 508 and divide it by 9. Because I have 1, 2, 3, 4, 5, 6, 7, 8, 9 items. So divided by 9. And that equals 56 point. There's a repeating decimal here. I'm just going to keep one decimal place, 56.4. So the median is 60. The mean is 56.4. So these are not too far apart. But I want to show you something interesting. What happens if I change, for instance, this value, the first one there, instead of 29, let's say it were 2. So I'm only changing one value. Notice, as far as the median, I haven't changed the values in the middle of my data set, only this first value at the low end. When I find the median, it's unchanged. It's still 60. However, I want to recalculate the sample mean, and I'll take 2 plus 35 plus 47, 53, 60, 64, 69, 71, and 80. This time I have 481. I still have 9 values. So by changing that one value, the mean has dropped from 56 to 53.4. We say that the median is resistant. And what that means is extreme values, and that could be on the low end or the high end. So I might have also changed this 80. Extreme values do not affect its value substantially. In this case, not at all. So as we move through topics of measures of central tendency and measures of spread, it'll be interesting to know which measures are resistant and which are not. So this quality of the median, the fact that it's resistant, makes it suitable, or I should say more suitable than the mean, for certain data sets. In particular, data sets where there are extreme values that might skew the mean. Lastly, for our final measure of central tendency, let's talk about the mode. The mode is the most frequent observation. Of the variable that occurs in the data set. Now, in this small data set, there's no mode. There's not one value that appears more often than any other. In fact, each value just appears just one time. However, if I had repetitions, perhaps of like 60, so if all of these had been 60, I would say that the mode for this data set is 60. It could be that you would have more than one value with multiple repetitions. If there were two, you might say that the data is bimodal. And if there were multiple numbers with a high number of repetitions, then you could say that it is multimodal. So let's tie this back in to some previous discussion of the shapes of distributions. In particular, let's first of all look at bell-shaped distributions. In a bell-shaped distribution, the median is right there in the middle where the peak of the bell is. Remember that the median separates the bottom half from the top half of your data, so it's this line of symmetry since this is a symmetric distribution. So this is the median. In a left-skewed distribution, it might be helpful to kind of think of this as being a solid, and to locate the median, you can think about where this object might balance. So I'm going to put a little triangle here, and we can pretend that this is balancing. Actually, I probably should have moved this over a little bit more to the right. And think that if this were a solid object, and I would think that the area or that's to the right of this line and the area that are to the left are about the same. So it would balance at this point. So I'd say that the median is here. That would also work if you had a right-skewed distribution and we wanted to find the median. We could think about where this might balance, and maybe it's about right here. So this would be the median. For a uniform distribution, so remember that's just where it's kind of has a flat line. Since this is also symmetric, just like the bell-shaped distribution, the median would be right in the middle. So what about the mean? For a symmetric distribution, the median and the mean should be equal. But for a skewed distribution, for example in this left skewed distribution, because we have some extreme low values, the mean will be pulled down, so to the left of the median. So in a left skewed distribution, the mean is less than the median. For a right skewed distribution, we expect the mean to be to the right of the median because we have some extreme values here on the far right that are going to pull our mean upwards. And so the mean, in this case, would be greater than the median. As far as the mode is always the peak. So it's the, in this case, the bell shape, that would be right there with the mean and the median. In these skewed distributions, the mode is the top, the highest point there. In a uniform distribution, there's no mode. Everything appears with the same relative frequency. And I'm going to stop again, and hopefully you can join me for the next video, and I'll show you some applications of these measures of central tendency.